Hello everybody, today we're going to get into a new subject of multivariable linear systems, and our objective is to be able to solve systems of linear equations using what's called Gaussian elimination. Okay, so let's get into it. What are these multivariable or multivariate linear systems? They're just linear systems with more than one variable, two or more variables, okay? Now, our goal here is to get these systems into what's called row echelon form. Okay, row echelon form, that's how we say this. Okay, now notice here that the left side of my system forms this sort of triangle. Okay, like so. A bit of a triangle there. Okay, and the last equation is solved for a variable. Okay, and then each equation above it, okay, contains what the variables in the equation directly below it. So this second row here contains the variable z as well as y, and then our top row contains the variables y and z along with x. Okay. Now, typically, we're not given a system, okay, in row echelon form already. We're going to be given something that looks sort of like this, okay. A typical system of equations might look like this, and our goal is to kind of manipulate it into row echelon form. And the process that we use to get it there is called this Gaussian elimination, okay. And our Gaussian elimination is really just operating on each of our equations in a way that reduces it down and gets it to this row echelon form. And these are the three things we can do when we're using Gaussian elimination. We can interchange two or more equations. Okay, we can kind of and reorder them. We can multiply our equations by any constant, okay, any non-zero constant. And we can actually add our equations together as well. We can add a multiple of one equation to another. So let's go ahead and see what this looks like in practice with an example. Okay, we're given our system and we're going to put it first in row echelon form using our Gaussian elimination, and then we're going to solve. Okay, so first thing I want to make sure I'm doing, I want to make sure I'm numbering my equations, okay, numbering each row in my system. Okay, it's going to help me with organization here. Okay, so the first thing I want to do, since the first row contains x, y, and z, I'm going to go ahead and see if I can't remove z from my second row. Okay, I'm going to remove z from my second row. So to do that, I'm allowed to actually multiply the first row by -3, okay? And I'm doing that because of this +3 here that I'm trying to get rid of. So since that's what I'm trying to get rid of, I'm going to multiply by -3 and then add row 2. And that's going to give me a new row 2. So when I do that, okay, we can see the operation here. My 3's cancel out, my 3 and my -3. I have -6 plus -1y. Okay, so that gives me -7y. And I get 9z plus 2z gives me 11z is equal to 87. Now, notice if you go back to the last slide where we had row echelon form, the first coefficient in each row was 1. Okay, but here I have a coefficient of -7. So I'm just going to multiply this row by the reciprocal of our 7 here. Okay, so I'm going to multiply by -1/7, and that's going to give me a new system that looks like this. Okay, my second row has changed to y minus 11/7z minus, or is equal to -87/7. Okay, and our third row has stayed the same. Okay, so now since that third row stayed the same, and I want to get that third row to just be z equals something, right? We're going to get this in row echelon form. Then first thing I need to do is remove x also from our third equation, our third row. Okay, so I can do that by just adding row 1 and row 3, and that's going to replace my row 3, whatever I get afterwards. Okay, so when I add them here, again, my x's go away. My x's go away, and I get 2 plus 1y, that gives me 3y, and I got negative 3z plus negative z, that gives me negative 4z is equal to negative 33. Okay, so that makes my system look something like this. And then I'm going to also try to remove this y from row 3. Okay, so I'm going to do that by multiplying row 2 by negative 3, and then I'm going to add that to row 3. Okay, so right here I'm multiplying row 2 by negative 3 here, and then adding that to row 3. So when I do that, I get that eliminates my y variable, and I'm left with 5 over 7z is equal to 30 over 7, so z is equal to 6. Okay, so now my system in row echelon form is going to look like this. Okay, so again, I want to make sure I'm keeping these numbered just so we can kind of keep track of what we're doing here. Now notice that since I've solved for z, I can just go ahead and use substitution. So I'm going to take a look at row 2, and wherever I see a z, I'm going to substitute in my 6 that we solved for. Okay? And when I solve for y, that gives me y is equal to negative 3. Now I can take a look at row 1, okay, and wherever I see a y, I'm going to input negative 3, and wherever I see a z, I'm going to input my 6, and when I solve, I get x equals negative 4, okay? So we would write our final solution just like this, okay, kind of like coordinates, and that again is saying x, y, and z, okay? And that's how we would write out our solutions for these, okay? So that's it for this lesson, nice and short one. Next time we're going to take a look at matrices with these systems, but until then, good luck with your practice.